Alright everyone, welcome back. In the last video we spoke about putting facets in our data, and now in this video we're going to be talking about using different geom functions. In ggplot, a geom is a geometrical object that a plot uses to represent the data. So in the case of bar charts we use bar geoms, and in line charts we use line geoms, and box plots we use box plot geoms. So these functions would be geom bar, geom line, geom box plot. But scatter plots break the trend and they use the point geom. So that being said, not all geoms accept the same arguments. So for geom point, you can set the shape of a point. So let's just go and just change our argument over here. So instead of color, we're going to use shape. And instead of class, because we have more than 6 variables over here, let's go and use the drivetrain variable. So putting that together, we can have different shapes. But if I want to go and use a different geom, like the geom that we're going to be using next, which is going to be geom smooth, right? The shape of the line can't be changed, right? Particularly, right? It's a little bit confusing, right? So one of the things that we could go and use, right, which ggplot is actually going and changing it to, right, as grouping the data, we can go and use, instead of shape, we'll use line type. So in this case over here, we get our data now grouped together by in line format, or just to go and give us a general summary, especially when we have a scatter plot and we want to just see the trend of the data. We can go and see that in the case of four-wheel drives, we have a general decrease in fuel economy as the engine size increases. But in the case of a four-wheel drive, it seems to be kind of something very interesting, where we have that initial decrease, but then we kind of plateau off. And in the case of front-wheel drive, we seem to go and have this V-shaped sort of fuel economy, which means that, you know, at a certain size, right, without knowing anything else about our data, that our engines are not fuel efficient at one point, right, and then we start and then as our engine goes and reaches, I think after 5 liters, right, it seems to go and start increasing. So one of the things that we can go and do to go and make our data more insightful, right, and be able to go and understand this story a little bit deeper, is to go and use multiple plots. So one of the things that we can go and do is combine this geom smooth together with a geom point. So there's 2 ways that I can go and do this, is that I can add this together and copy the mapping and go and add, I guess, the additional group that I think would be insightful, which is going to be the class variable, and we add it. But one of the problems with this is that I'm repeating myself with the arguments. So in order to make my life easier, right, I'm going to go and take out the arguments that I'm going to be using all the time. So in this case, right, I can put the mappings up here. So let's put the mapping over here, and then I'll put the aesthetics that I'm always going to be using. So I'm going to go and put in the engine size and our fuel economy, which is what we're going to be looking at for these plots in general. And I can take these out of our other plots. So we can go and just break it, strip it down to going and seeing what each plot is highlighting in particular. So rerunning this again, we get the same plot, and we can also have with this plot a broader picture of what's going on in this story over here. So in this story, we see that our V-shaped recovery well, not V-shaped recovery, our V-shaped trend that happens with our engine sizes seems to be attributed to the fact that on the improved fuel economy, it seems to be coming from our two-seater cars, which, as we saw earlier, seem to be smaller cars, right? And even though they have bigger engines, right, that could explain why they have better fuel economy. And in the case of our front-wheel drive cars, it seems to be that our trend is muddied slightly by an outlier over here in the case of a minivan, where all of a sudden we're not necessarily plateauing, but we seem to go and have a outlier over here telling us that it's plateauing. So we can also filter our data and look at a particular part of the data and at a particular trend, because this right now is pretty confusing. So let's say I'm just looking at the subcompact cars in my geom smooth function. I can go and write the following. I'll put in the data argument, and then I'll write filter. Right, because we're using tidyverse, we don't need to install the package which it belongs to, which is dplyr. We could just go and write filter. We'll talk about what filter does later on, but just know that what we're going to do is we're going to isolate the data that we want to plot. So we're going to just put it in our data set, and then we're going to write the class variable is going to be equal to subcompact. Right, I'm going to go and put this on a new line so I can see what's going on. And running this over here, we have here, what's the error that's going on over here? We have the geom smooth, we have the data filter class equals subcompact, standard error. And then, oh, so the mapping over here is needs to be taken out over here. So once we take out the mapping variable, we should have this cleaned up. Okay, fine, perfect. So now we have our data over here, and we have a clearer trend of our data being isolated to the subcompact vehicles, and how it fits with the broader scale of our data, and what the trend looks like. So that's all for now. I hope you found this video insightful, and I hope to see you in the next video.